Now in this lecture we will be seeing what is project crashing and how to do it. Project crashing means systematically reducing the completion time of the project step by step. Now in this process of reducing the time, the costs will come into picture, and that is called time cost trade-off. Trade-off means you sacrifice something to gain something. So there are two types of costs. First are direct costs. Direct costs are related with resources. So if we need more resources, direct costs will increase. And second are indirect costs, and they are the overheads, and they are vary with time. So they are related with time. So if we take more time, there are more indirect costs. If we complete in less time, indirect costs will reduce. So this cost behavior will look like this on the graph. Indirect costs, since they vary with time, as time increases, indirect costs will increase. Our objective in crashing is decreasing the time. So we want to have the less completion time. So we are decreasing the time. So as we decrease the time, see, indirect costs, they will start to decrease. Okay, that is first one. But direct costs, they are related with resources. So if we want to reduce the completion time, then obviously we need more resources. Your resource requirement will increase, whether it is manpower, machines, or any other resource. So as resources requirement increases, the direct costs will also increase. So when we are reducing the time, the direct costs will increase. Okay, so their behavior is opposite to each other. Total cost is equal to direct cost plus indirect cost. The behavior of total cost is like, when we start reducing the time, initially the total cost will start to decrease. Then it will come to a point where the total cost is minimum, and then beyond this point again it will start to increase. So the objective of project crashing is to find this point where the total costs are minimum. So this point corresponds with optimal cost, or you can say minimum cost. And when you project this point on the time horizontal axis, the corresponding time is called optimal project completion time, because it is corresponding with optimal cost or minimum cost. So the objective of project crashing is to find the time corresponding with optimal cost and optimal project completion time. Okay, so now this is the question given for project crashing. The time and cost estimates and list of activities of a project are given below. This is a list of activities. This is the time given in days, normal time and crash time. So this is the normal time of activity. Crash time means, for example, for A, normal time is 4 days, crash time is 3. It means from 4 days we can reduce it to 3 days. It means by 1 day we can reduce the activity. This is the cost, normal cost and crash cost. It means for A, for the normal time of 4 days, its normal cost is 60 rupees. But if you want to reduce it to 3 days, its cost will become 90 rupees. We have seen earlier that when we crash the activity, direct cost will increase. So these are the direct costs, normal cost and crash cost. And if you are going to crash the activity, direct cost will increase. So normal and crash time is given for all activities. Normal and crash cost is given for all activities. Indirect cost here, it is rupees 60 per day, that is given to us. We have seen earlier that indirect cost is the cost of overheads, and it is related with time. As time will change, indirect cost will change, and that is why it is given on a per day basis. So the question is, crash the project systematically and find optimal project cost and optimal project completion time. Now when we start solution, the step number 1 is drawing the network diagram. Okay, so when we draw the network diagram, the node relationship is given here. Accordingly, we have plotted the network diagram. A is 1, 2. Okay, A is 1, 2. B is 1, 4. C is 1, 3. D is 2, 4. E is 3, 4. F is 2, 5. And G is 4, 5. And for network diagram, we should always use the normal time, because crashing we have not done till now. So network diagram, you should draw always with normal time. Now after network diagram, we will find the paths in the network. So the first path is 1, that's AF, going from above. First path AF, that is 4 plus 7, 11 days. Second path is ADG, that is 4 plus 5, 9, 9 plus 4, 13 days. Third path is BG, straight line. That is 6 plus 4, 10 days. Fourth path is CEG. That is 2 plus 2, 4, 4 plus 4, 8 days. So 4 paths are there, and the longest path is ADG, 13 days. So this is our critical path. Okay, so we will highlight ADG. Okay, so critical path is ADG, and so we can say that, okay, now completion time is 13 days. Now see here, this is the normal completion time. So we can say answer number 1. Normal project completion time 13 days. Now we have to calculate the normal project cost. That is equal to direct cost plus indirect cost. Now for the direct cost, we should refer to the original cost data. Now if you see the table in the question, this is the normal cost. These are all direct cost only under normal conditions and under crashing conditions. So under normal conditions, the direct cost of each activity is given, and when we do summation of this, when we add this, the summation of all these normal costs, that will give us direct cost, and that summation, when you add this, you will get a total of 713. So we can say that our direct cost is rupees 713. Now indirect cost in the data it is given as rupees 60 per day, and our completion time is 13 days. So 713 plus 13 into 60, because for 13 days, okay, 60 rupees per day into 13. So that will be 713 plus 13 into 60 is 780. So 780. It means our total cost will be rupees 1493. Okay, so this is our answer number 1. Normal project completion time is 13 days, which is equal to critical path. Normal project cost is direct cost plus indirect cost. Direct cost is summation of all the normal costs given in the question, that is 713. Indirect cost, project completion time is 13 days, 13 multiplied by 60 rupees per day, so 780, and this is the final cost. Okay, so this is our answer number 1. This is step 1. After this, the crashing procedure will start, and the crashing procedure, the next step is preparation of this table. This is called cost slope table. Cost slope means crash cost per day. It means if you crash the activity by 1 day, how much cost will increase. How to calculate this? This crash cost per day or cost slope is equal to delta C divided by delta T. Delta C means difference in cost, and delta T means difference in time. Okay, so for example for A, so you take the difference between crash cost and normal cost and divide it by difference between crash time and normal time. Say for example for A, see here the difference, crash cost is 90, normal cost is 60, so difference is 90 minus 60 divided by difference in time 4 minus 3. So for A it is 90 minus 60 divided by 4 minus 3, that is 30 upon 1, so 30. It means for activity A, crash cost per day is rupees 30. In the same way, you calculate the cost slope for each and every activity. So it will be 30, 50, 22, 50, nil. For E it is nil because crash cost and normal cost is same. It means we cannot crash the activity. Okay, so it is nil. And then for F it is 30 and G is 70. So this is the cost slope of each activity. Then we will also find what is the crashing limit. See, this is also called as crashing limit. Maximum possible crashing means crashing limit, by how much we can crash, by how many days we can crash. So for example for A, the crashing limit, that is the normal time minus crash time. Normal time is 4 days, crash time is 3 days. So 4 minus 3, 1. It means we can crash activity A by only 1 day. And similarly, we will find the crashing limit of each activity. Okay. So now this initial basic information of crashing we have prepared, and now we will go in the crashing procedure. Okay, so now we will start with the crashing procedure. This is the crashing table. First column is the details of crashing. Second is paths. There are 4 paths: AF, ADG, BG and CG. And the last column is cost, direct cost, indirect cost and total cost. The first line is conditions before crashing, that is the normal conditions. The AF was 11 days, ADG was 13 days, which is a critical path. BG was 10 days, CG was 8 days. And the cost where direct cost was 713, indirect cost was 780. 780 was like 60 rupees per day multiplied by 13 days. And total cost was 1493. Now we will start with crashing. The first principle of crashing is we should crash only critical activities. Now our critical path is ADG. So we will mark those activities A, D and G. So we can start either with A or with D or with G. Which activity we should start with depends on the cost flow, crash cost per day. So wherever the cost is minimum, we will start with that activity. For A it is 30, D is 50 and G is 70. So A is the best because it is the most economical. So we will start with A. Okay. So we will say here first crashing A by 1 day, and we should always crash by 1 day only at a time. That is what is called systematic crashing. So we are going to crash A by 1 day. So now wherever there is activity A, that path will reduce by 1 day. So here there is A, so it will become 11 minus 1, 10 days. Second is ADG, so this will become 13 minus 1, 12 days. This and this, there is no A here, so it will remain same. Now direct cost will increase in the crashing process. So it is originally it was 713 plus by how much it will increase? It will increase by 30 rupees because crash cost is 30 rupees. So 713 plus 30. So now it will become 743. Indirect cost is 60 per day and now completion time is now 12. Okay, from 13 it has become 12. So 12 into 60. So it will be 720. So total cost will be 720. Now the total indirect cost will be 720. So now you add 743 plus 720. So now it will become 1463. So now if you compare, the total cost has decreased. Okay. So now we have crashed A by 1 day. Okay. Now again we come back to this table, and now A 1 day crashing we have done. So this 1 day was available to us. Limit was 1 day. 1 day we have done. So now there is no possible crashing. It means activity A is now over. So now we have only 2 critical activities, D and G. Okay, so either we can crash D or we can crash G. For D, cost flow is 50. For G, it is 70. So D is more economical. So we will do crashing of D. So second crashing. D by 1 day. Now wherever there is D, that path will reduce. This will remain same at 10. ADG will reduce by 1 day. So it will become 12 minus 1, 11. BG same as 10 and CEG same as 10. Now again direct cost will increase. So 743 plus. Now the cost flow of D is 50. So it will increase by 50. It will become 793. Indirect cost. Now the completion time is 11 days. Okay. So 11 into 60. That is 660. Now you add this. So this will become 1453. Okay, so now the new total cost is 1453. Now you compare this with this, again there is a decrease. So our direct total cost is decreasing. Okay, now D, we have done crashing by 1 day. Now see the last column. Maximum crashing possible was 2 days. Out of that 1 day we have done. So now only 1 day remains. Okay, now again we have 2 critical activities. Same principle. For the third crashing, 2 critical activities are there, D and G. So again, whatever is more economical, we will crash. So D is 50, G is 70. So we will crash again D by 1 day. So third crashing is again D by 1 day. So wherever there is a D, that path will reduce. AF will remain same. ADG will reduce 11 minus 1, 10 days. BG will remain same 10 and CEG will remain same at 8. Now direct cost 793 plus crash cost per day is 50 for D. So 793 plus 50. So that will become 843. Indirect cost, now the ADG critical path is now 10 days. So 10 into 60. So it will become 600. 843 plus 600 is now 1443. So 1553 and 1443, again there is a decrease. So our total cost is decreasing. Now see this table now. Now D, 1 day was available, we have used that 1 day, so now it becomes 0. Now D cannot be crashed, now D is over. Okay. Activity E is nil and 0. Activity E cannot be crashed. Okay, so E also you should ignore now. Now see this table again. Now our critical path ADG, originally it was 13 days. After 3 crashings, it has come down to 10 days. It means now critical path is of 10 days. And there are 2 more paths, that is AF and BG. They are also of now 10 days. It means they also now become critical. So this means now we have multiple critical paths. So we have 3 critical paths, AF, ADG and BG. So now these activities will also become critical in the table. AF, A is over, so we can ignore that, but F, now F has become critical, so mark it with a star. Then here BG, B and G. G is already critical, but now B also becomes critical because path BG. So path BG has become 10 days critical path, so activity B also becomes critical. Now what happens is, when you have multiple critical paths, the rule is, when you are doing the next crashing, the 10, 10, 10 should become 9, 9, 9. It means the equality should be maintained. It can't be like one path is becoming 9 and other is remaining 10. So all 3 paths now should reduce simultaneously. So the best possible way of reducing all 3 paths simultaneously, if there is a common activity in the 3 paths, you reduce that, then all 3 paths will reduce automatically. Otherwise, you select one activity from each path. Now if you see, in ADG and BG, activity G is common. So we can reduce G. So when you reduce G, ADG and BG will reduce simultaneously. So we say 4th crashing, G by 1 day, and this is for path number 2 and 3. But in path number 1, G is not there. So path number 1, only 2 activities are there, A and F. So but A is already over, so we have to crash now F. So G by 1 day and F by 1 day. This G is for 2nd and 3rd path and F is for 1st path, that is AF. Okay, so when you reduce G, the 2nd and 3rd path will reduce simultaneously. So now the crashing is G by 1 day and F by 1 day. So AF, it will reduce by 1 day, it will become 9. ADG, so G is there, so 10 minus 1, 9. Then BG, 10 minus 1, 9. And now the equality is maintained. And CEG, here also G is there, so this will also reduce, so 8 minus 1, 7. Okay, so now 10, 10, 10 it was, and now it is 9, 9, 9. So it is very important that equality should be maintained. Now the direct cost, original cost 843 plus cost of G is 70. Okay, cost of G is 70 plus cost of F. Cost of F is 30 because we have reduced 2 activities, G and F. So we have to take cost of G and F. So now the new cost will become 943. Indirect cost, completion time is now 9 days. So 9 into 60, that is 540. Now you add this. So 9 plus 1, it will be 1483. Now if you see 1483, 1443 and 1483, now the total cost has started to increase. It means we have reached our optimal point, and the optimal point is the minimum cost. See, we started from 1493 and we came up to 1443, and again now the cost is increasing. It means 1443 is our optimal cost. So now we can stop the crashing procedure because we have discovered what is our optimal cost. Okay. For the reference, we will give an effect here. We have reduced G by 1 day, so out of 2, 1 goes, 1 remains. We have reduced F by 1 day, so out of 2, 1 goes and 1 remains. It is still possible to crash this network further because there are many activities which are remaining. F is remaining by 1 day, G is remaining by 1 day. So we can also go in fifth crashing, but it is not necessary because we have already found our optimal answer. So we can stop here. So now we will write our final answer. This is answer number 2. Answer number 1 was the answer of what is normal project cost and what is normal project time. Answer number 2 is what is optimal project cost and what is optimal project completion time. Now 1443 is our optimal cost and the corresponding time is 10 days. Okay. So that is our optimal project completion time. Okay, so now our solution is